Welcome back, y'all. Oh, snap. I ain't got the vibes right. Hold on. Let me get the vibes right. Let me get the vibes right one time. Get the diffuser. Some more water in there. We're going to wait on the water. Go. Get my candle lit. There we go. All right. Let's some water. Got my water. Welcome, y'all. Appreciate y'all for tapping in. We back with another coding journey live. We learning. Let me put my phone on do not disturb, y'all. We gotta get rid of these distractions, y'all, for real, man. I'm not gonna go into a rant, but this phone be distracting, y'all. You gotta throw that thing away while you working to lock in for real. Put that thing in the other room. Um yeah, so let me get that out the way. Let me make sure my sound is coming in clean. And we're gonna get started. We're just gonna get started. Um I'm not popping up on my own feed. Let's see. Okay, there we go. Go ahead and hit the like button. Okay, so it's coming in clean. So had a lot going on yesterday. Dealing with some legal matters here, but nonetheless, I am locked in, y'all. I'm locked in. I'm ready to go. So I'm gonna continue where I left off with my CS50. Okay, with CS50, make sure I'm logged in and everything, and we'll continue this course. Disclaimer: I do not own the rights to any of this content or material. This is just me using the. Well, let me just read it. This content is created as a part of my personal learning journey following Harvard's CS50 course. All CS50 content shown or referenced is property of Harvard University and CS50. This video falls under fair use for educational purposes as I document my learning process. I'm not affiliated with Harvard University or CS50. To access the official course materials and content, please visit cs50.harvard.edu. All right. All CS50 lecture content belongs to its respective owners. All right. So let's is that even the right URL? Yes, it is. It'll go to edx.org/cs50. So let's paste that in there too. Or we'll do that for another time. So where am I at with it? Let me go to profile or dashboard. My fault. I'm going to dashboard. I'm still learning to navigate this thing. Here we go. I'm gonna get in that Python. Once I get in that Python artificial intelligence, ooh, I know there's a big thing about people talking about, Mark Zuckerberg and what's the boy's name? Jensen Huang. He was born in '93. Ain't no way. Oh, he was born in '60. I was about to say, what the hell? Oh, he was the CEO since '93. So that boy got gray hair. Yeah, Jensen Huang and Zuckerberg. They talking about don't learn how to code. I'm like, bro, y'all, all the people y'all have are coders. You know what I'm saying? All the people on your staff is coders for real. I'm sure y'all got some marketing and some sales and all that stuff, but man, I don't believe the hype. If you just, I think what I think they're so caught up in their own space, of it's just like when you in a field so much, you don't realize what's happening outside of the field. So, what's a good example? Like if you just rich and you only be around rich people and you just do rich things, you don't know that people living check to check. You know what I'm saying? You don't know people is sacrificing, you know, food to drive to work so they can make money or something like that. Or some people is not eating so their kids can eat, stuff like that. You don't even have, that's not even your scope of understanding. So I think when they saying, oh, software developers, don't learn the code, I think they're saying that from a perspective of thinking that people already have a basic understanding of code. Like that's just a natural thing that people have when that's not the case. I think, well, in my opinion, having that base understanding of coding and computer science, that's going to be like, just having that fundamental understanding is going to set you apart, and it's going to kind of raise your awareness and your ability to use these new technologies that's coming out in a new way. So you're not just a consumer; you could be a creative. So we're gonna rock with this, y'all. I appreciate y'all for watching me on my journey. I'm gonna lock in. I'm gonna try to get 2 hours in the day, and we're just gonna rock through this. Maybe I might just finish this video because I was about 30 minutes in. I didn't go back and watch it, man. It's got a lot going on, but it's 12:30 right now. I'm gonna lock in and just get it popping. You know what I'm saying? Whoa! Put that in my headphones so I can really tap in, tap in. Let me make sure y'all can still hear me and make sure when this plays, it's coming out. Let's see. Oh, hold on. I gotta share my screen probably. That'll help. Nope. So I guess I don't need these bad boys. I like wearing these though. It made me feel like I'm a streamer, but I don't need it. Okay. There's probably a way to work around that. I still haven't used OBS to do any of my streams on YouTube because it's just been easier just to go straight from YouTube. But I might have to so I can get the sound and wear the headphones. But let's see. Press play on this. Dang, now I'm questioning to see if I even had my last video. Dang. Let's see. Live. Oh, y'all got all my. Okay. Okay. So that video had the audio on that popping. That's good. So let's go back here. Damn, I didn't want to share all that. Okay, well let's try this again. Let's try this one more time. Also share tab audio. Yes, please. We want this one. C is 50. Share. Now let's try that.
And then join these two phrases. Here you have a technical term that is a bit. A bit is just a binary digit, which is to say it's a 0 or 1. And this is in contrast of.
Well, let me try one more thing. Maybe I might be able to put the headphones on. Let's see.
course, with the system you and I know as the decimal system, dec implying 10. Because in the real world, you and I daily use 0 through 9.
Okay. We back.
Which is 10 possibilities. Computers only use 0 and 1. That is to say 2 bits
How's
to
this phone not
represent
stuck,
information instead. So how do we represent this information, especially when at the end of the day, what we're using are indeed computers and electronic
go back to
and binary.
Word.
Clear. Or a text message, or
Just
2, how about 3, 4, how about 5, 6, 7. Going on underneath the uppercase and lowercase, numbers on the keyboard shall be represented with this pattern of zeros and ones. 0, 1. So knowing now that computers only contain more, of course, between binary and decimal. But you can do different things. It's just simple on and off. And case in point, I don't want to really be dramatic and turn off my computer, but if I pulled out the power plug, that could be off, literally, aka 0. Plug it back in, that's a 1. There's just a cleanliness and simplicity to that. Other questions or confusion that we can clear up? No? Okay, so if you're in agreement for the moment that, okay, using just zeros and ones, we can represent any number we want from 0 on up, let me propose that we do more useful things with our computers and our pockets and desktops and laps, like represent letters for the sake of Google Docs, Microsoft Word, or any kind of text that we might want to write. So knowing now that computers only use zeros and ones in hardware like transistors, how could you represent something like a capital letter A in English inside of a computer, which of course is not a number anymore? Like, what could we do? Yeah. Okay, yeah, so we could take the alphabet, A through Z in English, and we could just assign each letter a number. And honestly, that is not only the correct answer, it's really the only answer. Because at the end of the day, if all you have are zeros and ones available to you, that is the entirety of the potential solution to this problem. So it turns out that, yes, capital letter A, some years ago, was decided by a bunch of people in a room, shall be represented with this pattern of zeros and ones.
1 0 0 0 0 0 1. Okay, that's an A.
0 1 0 0 0 0 0 1.
Oh, I read it right to left. Okay, yeah. So you read it to left to right. I don't know why it says 1 here, so I just thought you read it this way, but obviously you read it left to right.
And now, trained as you are to do a bit of quick binary math, what decimal number is used to represent apparently capital A? So 65, because it's 64 plus 1. Plus 1 times 1 is 65. What is B? Turns out it's 66. What is C? 67. So they kept things simple there on out. Might have been nice if A were 0 or maybe A were 1, but nope, we're stuck with 65 instead. But everything after.
Okay, that's a good note to have. A equals 65. B equals that's why 66. And then he said, so we had 0, or we got 128, 64, 32, 16, 8, 1. No, 8, I'm tripping. 128, 64, 32, 16, 8, 4, 2, 1. Yeah.
That is very much predictable. And in fact, for lowercase letters, there's a whole other set of numbers, such as lowercase a happens to be 97, lowercase b happens to be 98. And
okay, see, that makes sense too, to have a lowercase. I just feel the need to write this down. I feel like it's like on some Jeopardy. This could be a Jeopardy question. He said 97. I done missed it.
Turns out that, yes, capital letter A, some years ago, was decided by a bunch of people in a room, shall be represented with this pattern of zeros and ones. 0, 1, 0, 0, 0, 0, 0, 1. And now, trained as you are to do a bit of quick binary math, what decimal number is used to represent apparently capital A? So 65, because it's 64 plus 1 times 1 is 65. What is B? Turns out it's 66. What is C? 67. So they kept things simple there on out. Might have been nice if A were 0 or maybe A were 1, but nope, we're stuck with 65 instead. But everything after that is very much predictable. And in fact, for lowercase letters, there's a whole other set of numbers, such as lowercase a happens to be 97, lowercase b happens to be 98, and so forth. But again, this is sort of like CS trivia, but what's important here is that they're indeed contiguous from 65 to 66 to 67 on up. That's something we're going to be able to leverage beyond the letter A alone. What is this system? What is this mapping that you yourself proposed? It's ASCII, the American Standard Code for Information Interchange.
ASCII. That's something you want to write down, people. American, you said what? American System Code for what? Something interchange. American Standard Code for Information Interchange. Okay. That's good to know. That's good to know. Let's continue.
And indeed, it was a bunch of Americans years ago who came up with this system. Unfortunately, at the time, they only allocated 7 and eventually 8 bits total for representing letters, both uppercase and lowercase, numbers on the keyboard as well, punctuation symbols as well. And so per our conversation a moment ago, if the Americans in this room, so to speak, only used 8 bits total, how many different characters can we represent with a computer in this story?
How many 8 bits? I guess it would be the sum total of 256 plus 128 plus. Let me just make sure. Let me just do some math to see if my math is mathing. 256 plus 128 plus what's that for 128? 1 or 84? Let me see, 128 divided by 2. Divided by 2. Divided by 2. 64. That's what I thought. Okay. So 256 plus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 511. Let's see, people. Let's see.
So only 255, technically 256, if we again start counting from 0. So that's not nearly enough, but it is to represent all human languages, but it is enough to represent at least English among some others. So here, for instance, is a chart of the ASCII mapping. And sure enough, if we zoom in on like this column here, 65 is capital A, 66 is capital B, ... 72 is H, 73 is I, and so forth. So there is a standardized mapping for at least all of these English letters. Well, suppose you were to receive an email or a text message or like a Google Doc containing this pattern of zeros and ones. So 0, 1, 0, 0, 1, 0, 0, 0, and so forth and so forth. So 3 bytes worth. 3 sets of 8 bits, that is to say 3 bytes, each of which
3 sets of 8 bits. So see, I need my little, this is binary. So this is A. Go to my notes. I'm pretty sure that's A. How many zeros is that? 4? I think I might have had too many zeros. 256, 128, 64, 32, 16. Oh, no, that's not A.
represents a single letter in ASCII. What message have you received? Well,
I don't
Do
know.
the math this time so we don't have to. Suppose what you really received was decimal 72, 73, 33. What message did you just receive?
Well, if A is 65, so we know 60. Oh, dang. See, this is crazy. 72. So 10 would be, okay, A, 65, 66 is B, 67 is C, 68 is D, 69, ABCD is E. Dang, let me see. 69 is E, 70 is F, 71 is G, 72 is H, high. So saying high was 33. 33 would be a number. So it would be, so we're going to 0. It would be a high 33. I don't know. High
If
something.
you recall the previous chart. High was in fact correct. Why? Because H is 72, I is 73, and wait a minute, 33. So here's H, here's I. 33, if we highlight it instead, happens to be an exclamation point. So like that is literally what is going on underneath the hood, so to speak, when you get a text message today that literally says in all caps and an exclamation point, hi, your phone has received at least 3 bytes, each of which represents a letter of the alphabet. Your computer is quickly doing the mental math to figure out exactly what numbers those are, and then looking up in the so-called ASCII chart in its memories, in some sense, what letter should you actually see on the screen there.
That's kind of crazy on the back end, knowing that, it's how many digits is that? He said 8, 1, 2, 3, 4. Dang. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, eight digits to get one letter. I mean, they're all ones and zeros. So it would be 8, 16, 24. 24 digits just to do 3 characters.
And so if you
that are all ones and zeros
were to then display that message, you would see it indeed in English as opposed to those numeric equivalents. How else might we use this then? Well, here again is that chart, and maybe just to
Okay, SQH. Hold on, what? Why? What are these? Are these like functions? Delete? Oh, I'm guessing that's delete. So we got your brackets, 90. So you got some punctuation before you get back to the alphabet. That could be confusing. But I'm curious about these first 31, 32, these first 32 characters.
To vary things, maybe take a little pressure off of me here. Why don't we try spelling something else? This time a different 3-letter word, but maybe 8 volunteers. Could we get a byte's worth of volunteers? And I can sweeten the deal with some stress balls in exchange. You just have to be comfortable coming up on stage and being on the internet. So yes, 1, 2, about 3, 4, about 5, 6, 7, and how about 8? Come on up. A round of applause for our volunteers. Yep, come on. All right, so what I'm going to have each of you do is represent a bit in a particular order. So if you want to just in any order, line yourselves up here facing the audience.
Shout out to the queen over there. And this dude looked like old boy from How High, the bike with the bike.
Come on over. All right, and we will have you represent, well, you got to see who ends up where. Scooch this way a little bit. This way, this way. All right. So you shall be the 1's place, and just hold that in front of you. 2's place, 4's place, 8's place, 16, 32, 64, and 128. And just compress yourselves a little bit if you could. So each of these folks represents a bit in a particular place. And let's say this. If you're just standing there sort of uncomfortably without any hand raised, we'll assume that you're representing a 0, quite simply. If your hand goes up, though, the audience should assume that you're representing a 1. And therefore, what we'll do is spell out a 3-letter word. And on each round of this, you'll either stay like this or you'll raise your hand. But first, let's actually meet some of our volunteers here, starting with position number 1. If you'd like to say your name, perhaps where you're from and or studying.
Hi, my name is Brooke. I'm from Indiana, and I'm studying biology and computer science.
Nice. Welcome.
Hi, I'm Becca. I'm from Maryland, DC area, and I'm studying electrical engineering.
Welcome.
I'm Addison. I'm from Maryland. I'm studying engineering.
Hi, I'm Sharon. I'm from Rwanda, and I'm studying CS and math.
Welcome.
Shout out to Sharon from Rwanda.
Hi, I'm Grace. I'm from Alabama, and I'm studying electrical engineering.
Welcome.
Hi, I'm Angelina. I'm from Maryland, and also I stay in Matthews.
Nice, Matthew. Nice.
Trying to get some points with the professor. I feel you.
And I'm studying applied math and econ, as well as environmental science and public policy.
Welcome.
Dang, sure.
I'm Owen Bells, and I'm from rural Virginia, and I'm studying CS.
Nice. Welcome. And
my name is Max. I'm from London. I'm also staying in Matthews, and I'm studying computer science and neuroscience.
Welcome aboard as well. If you're wondering too why I was wearing these glasses at the start, so very common on the internet nowadays is these POV videos. So it turns out these Ray-Bans actually record video footage, and we have a couple of them, and we thought we'd offer them to a couple of volunteers if everyone wants to record their point of view for everyone here. And Vlad here is going to help make sure they're recording. Second volunteer? Yes, number 2. All right. So
I got to get a pair of those. I ain't going to lie.
Vlad gets those set. On the backs of your pieces of paper, you have instructions for the following 3 rounds. Each round represents a letter. The audience participation part of this is to actually do the mental math to figure out what number these volunteers are representing. So go ahead and execute round 1, either keeping your hand down or raising it appropriately. OK, what number are our volunteers here representing?
What number is 66?
66.
Okay, I need the chart. Let me go look at the chart. Oh, that's A. That's a capital. Oh, that's a capital B.
Because we have a 64 plus a 2. That then maps to what ASCII letter? B was the first letter. OK, hands down. Round 2, go.
How do they know who to raise?
A little harder. What's
Okay, 64 plus 8, you got 74 plus 4, 78, 80.
It's now being represented? I'm starting to hear it. 79.
Oh, what? 64 plus 8. Oh, my bad. I did. Yeah, I did this at 6. So 64 plus 8. That'll be 72 plus 4 would be 76, 77, 70. Oh, I didn't see the 1. 79.
Is in fact correct. 79 because we have a 64 and an 8 and a 4 and a 2 and a 1. So if it's a 79, we have the ASCII letter O. Okay, so we've got B, O, and then lastly, third round, go.
It's going to be boy probably. Let me pull up my ASCII chart so I can look at it like they looking at it. Oh my God. Okay, let me get a. Oh, they ain't got the ASCII. Oh, is this the one? Let's see. Oh, okay. Oh, it's 79. So let's see what we got. We got 64 plus 16. So that's 0, carry the 1, 70. Wait, yeah. 1, 7, 8, 80, 87. That's what I got. And the 87 would be W, bow.
We have 0, 1, 0, 1, 0, 1, 1, 1. What number is this? 87, which spells the letter
bow.
W, which spells the word not bow. Take a bow if you could. All right, a round of applause for our volunteers here.
Oh man, the English language. Bow? Anyways.
And come on off this way and help yourself to a CS50 stress ball. Thank you to our volunteers. So this is only to say we've now agreed on how we can represent numbers from
Why my boy talk so fast, man? Slow down.
0 on up. We've agreed on how we can represent letters, but at least letters using ASCII. And in fact, these are more than just decoration. In fact, there's a little bit of trivia by lecture's end. If you want to come up for your very own CS50 stress ball, turns out there's 64 light bulbs at the foot of the stage here. If you break them down into 8-byte or 8-bit or single byte chunks, there's an 8-letter word that happens to be spelled out today using this here ASCII chart. So today's mystery is, what exactly is that there word?
8.
But of course, if you have only 8 bits, you can only represent like 256 characters, which sounds like plenty for English, and indeed it is. 0 through 9, A through B, capital and uppercase and lowercase, as well as punctuation. But there's so many other human languages in the world that have other characters. For instance, we have not just the English alphabet we might see here on a US English keyboard. We have accented characters. We have various Asian languages have even many more glyphs. We need more than 256 possible characters. And so nowadays, computers do not just use 7 or even 8 bits. They might use 8 bits for some letters, like all of the English letters. They might use 16 bits for certain other languages, maybe even 24 or 32 bits. And fun fact, if you have 32 bits, and we have more than that on the stage, if you've got 32 bits, you can actually represent as many as 4 billion possible characters, which is quite a bit. No pun intended. So what else can we represent? Well, the goal of this system, not just ASCII, but something known as Unicode, which is a newer standard, is to be backwards compatible with ASCII. So
Unicode. Well, he said 32 bits is
trivia by lecture's end. If you want to come up for your very own CS50 stress ball, turns out there's 64 light bulbs at the foot of the stage here. If you
I wonder what this spells. So this would be 1, 2. That dude's head in the way. I can't tell if it's a light bulb right behind his head. Probably 1, 2, 3. I don't know if it's on or off, so I won't be able to even. He got his head in the way. Okay, but yeah, he said Unicode. Let me go back to my notes. Unicode. Then let me come back here. This is day 2. Or this would be day 6 for me, at least. That's day 1. Okay, day 0, 50 notes, binary scratch notes.
break them down into 8-byte or 8-bit or single byte chunks, there's an 8-letter word.
Single byte chunk. So 8 bits is a byte.
That happens to be spelled out today using.
Is that right? 8 bits is a byte. Yes, it is. So 8 bits is a byte. Byte is 8 bits. Okay, that was in my yesterday notes. I'm just gonna put it back in there. 8 bits is a byte.
This here ASCII chart. So today's mystery is, what exactly is that there word? But of course, if you have only 8 bits, you can only represent like 256 characters, which sounds like plenty for English, and indeed it is. 0 through 9, A through B, capital and uppercase and lowercase, as well as punctuation. But there's so many other human languages in the world that have other characters. For instance, we have not just the English alphabet we might see here on a US English keyboard. We have accented characters. We have various Asian languages have even many more glyphs. We need more than 256 possible characters. And so nowadays computers do not just use 7 or even 8 bits. They might use 8 bits for some letters, like all of the English letters. They might use 16 bits for certain other languages, maybe even 24 or 32 bits. And fun fact, if you have 32 bits,
let's see what this is. 32 bits. He said a couple billion. He said 4 billion.
and we have more than that on the stage. If you've got 32 bits, you can actually represent as many as 4 billion possible characters, which is quite a bit. No pun intended. So what else can we represent? Well, the goal of this system, not just ASCII, but something known as Unicode, which is a newer standard, is to be backwards compatible with ASCII. So humans left all of those other numbers alone, 65, 66, 67, and so forth. But they added to it a superset of representations that maybe are 16, 24, or 32 bits. The goal being to be able digitally to represent all human languages, past, present, and future, and even through pictograms, things like smiley faces and the like, even people, places, things, and emotions that transcend human language. And in fact, odds are within the past few minutes or hours, most of you have used one or more of these here emoji, these pictograms, which it turns out are just characters on a keyboard. You might have to hit a special button to pull up that form of the keyboard, but these are just here characters. And so these emoji have exploded in popularity for a number of reasons, one of which is, my God, what are we going to do with 4 billion possible patterns of zeros and ones? We can start to kind of have some fun with it and represent things beyond English and human languages alone. Now, as an aside, when it comes to Unicode, it turns out Unicode years ago standardized this pattern of 32 zeros and ones to represent just one of those emoji. So
smiley face.
Emoji tend to use even more bits here. Anyone know what decimal number this is?
Oh yeah, let me just okay, so well, you're heading away, first of all, my boy. So no.
This is not a fun mathematical exercise. The spoiler is 4,036,991,106 is the decimal number that actually represents, as of present, the most popular emoji in the world. Does anyone want to hazard a guess what emoji this here number represents?
A smiley face.
Hearts, no, but it's actually this so-called face.
I use that one a lot, I'm not gonna lie.
With tears of joy. So perhaps think about the frequency that you send that one. And even though it's obviously a picture on the screen, sure, it actually is more like a font, because underneath the hood, it's indeed just a pattern of zeros and ones or a decimal number.
I didn't expect that. I should have guessed that though. That's the one. All right, man. Let me time out, y'all. I gotta go. I'll be right back. I gotta go grab a snack. Let's get interesting. I gotta grab my popcorn. Y'all chill here, you know what I'm saying? Let me put y'all on some of my I'm gonna put y'all on some of my music that I've been making, y'all. Code mode, you heard? I don't know why they ain't. Anyways. Oh, wait a minute. I gotta switch my. Put y'all on this real quick. I'll be back, y'all. Hold up. Intermission. Oh snap! My stream done froze on me. Check, 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 check. Dang, my freeze done froze on me. At least on here. I mean, it's still live, but let me see if I can refresh this. You know. Oh Lord, what's going on? Come on, man, don't do it like that. Dang, y'all. I was trying to take a break. I might have to get off. I'm back on. That's crazy. I never had no internet problems. I have, but like not in a long time because I had to make it. Xfinity guy come out and fix it, so I guess I'm gonna have to. That's crazy. Dang, y'all. All right, in the stream. Whether in the stream coming or going, y'all. Hold on. Dang, how would it be full? Heck, that's whack. All right, y'all. I'll be back, man.